This is TWIS, This Week in Science, episode number 773, recorded on Wednesday, May 13th, 2020. Canine COVID Angst. Welcome to the show. I'm Dr. Kiki. Tonight, we will fill your heads with teen angst. And that's pretty much it. But first, thanks to the Burroughs Welcome Fund and our Patreon sponsors for their generous support of TWIS. You can become a part of the Patreon community at patreon.com/thisweekinscience.
Disclaimer. The following hour programming has not been peer-reviewed. For that to be possible, this show would need to have peers. At best, there might be a few pre-recorded, post-editing, published slick shows that can be considered in the wheelhouse of what we do. But since there are no other live science news conversations being brought direct to the public within the week of that science's release, we simply cannot be peer-reviewed. But we can bring you the findings of scientists. We can bring you papers that have been peer-reviewed, sourced from institutions that are dedicated to the scientific process. And while we may wander about the subject matter with our own wonderings aloud of what the stories mean, how they might impact the world, and where they might lead next, we encourage you to do the same, to actively participate in the conversation about the world in which you live, because your review of the stories we talk about is the only reason that This Week in Science is coming up next.
I've got the kind of mind that can't get enough. I want to learn everything. I want to fill it all up with new discoveries that happen every day of the week. There's only one place to go to find the knowledge I seek. I want to know what's happening. What's happening? What's happening this week in science? What's happening? What's happening? What's happening this week in science?
Good science to you, Kiki and Blair.
And a good science to you too, Justin, Blair, and everyone out there. Welcome to another episode of This Week in Science. We're back to talk about science, to bring you the world as we see it from our curious perspectives. That's right. We've got curious perspectives here on TWIS. I have stories for you this week about, what did I bring? I brought stories about COVID, because we'll have our COVID update in a second, chimeras, and tools. Justin, what did you bring?
Chimeras, those are cool. What did I bring? I've got microRNAs to the rescue. Why your JJ might be in better shape than you think it is. Hidden islands of human migration and outrunning a Tyrannosaurus Rex.
Ooh, I'm glad I don't actually have to do that today.
But they eat things that are already dead, right? So it's okay. They wouldn't actually be chasing you.
Hopefully not. Blair, what's in the animal corner?
I have sea turtle mothers. I have the adolescent dogs and some teen angst from them. And I also have an update on the Tully monster.
Ooh, monsters. We love them. We love to talk about the science about them. As we jump into the show, I want to remind you that if you are not yet subscribed to the TWIS podcast, you can do that. It's pretty easy to find us on all podcast directories. Look for This Week in Science. You can also find us on YouTube, on Facebook. Look for This Week in Science. And our website is twis.org, TWIS.org. But let's get into this aforementioned science. Yeah. All right. The COVID update. What is going on this week? Well, the World Health Organization COVID-19 situation report for May 12th reports 4.09 million confirmed cases and 283,153 deaths worldwide. The Johns Hopkins CSSE dashboard reports 1.38 million U.S. cases have been diagnosed and 82,806 deaths as of 12:30 p.m. today. So the numbers are going up. We have exceeded 80,000 deaths, and we're looking for a vaccine. This week, exciting news. Moderna, which we have talked about previously on the show, which is a company that works on messenger RNA vaccines, they have had positive results from their phase 1 trials in Seattle. This is a clinical trial that is also funded by the NIAID. And the exciting thing is they have gotten fast track approval from the FDA to move forward on their clinical trials. They are pushing forward on phase 2 as we speak, even though they have not yet published their phase 1 clinical trial results. They are hoping to get the phase 2 underway this summer, very shortly, phase 3 very shortly after that, and we'll see where it goes. The way that clinical trials work, phase 1 is a safety test. All they do is inject people with the vaccine to see whether or not any bad things happen to them. And apparently, their results are positive enough that everyone is very excited about them moving forward, hence the fast tracking. This does not mean that it treats or can protect people from COVID-19.
Just means that just means that the treatment itself doesn't seem to be killing anybody.
Exactly. I mean, but not just not killing anybody. It doesn't, we don't know yet. They haven't published the results and they haven't gotten approval to actually publish the results yet. But apparently in the small governmental group of people that they're sharing the results with, it was enough for the FDA to accelerate their movement through the clinical trials.
It at least killed less people than COVID would.
I imagine it didn't kill anybody to be moving ahead. Yes. So someone, Matt Elliott in the YouTube or the Facebook chat room, sorry about that, the Facebook chat room is asking if we can explain what it means for the fast tracking process. So the fast track process allows this normal, the normal process of data analysis, publication, and extended commentary period from peers. So there's an extended period of peer review to allow for lots of experts to be able to weigh in on the results of phase 1, phase 2, before each of the phases are advanced through. The usual pace of advancement through clinical trials allows for a lot of commentary and a lot of feedback. And what the fast tracking does is it is pretty much based on the data that is reported by the group doing the clinical trial. And if the data, as in this case, is predominantly positive, significant, I don't know exactly what the p-value is that they're looking for. I don't know. They have particular success markers that they set out before the trial is even undertaken. And if those success markers are hit, then that allows them to move forward with the trials. For the phase 2 and phase 3 trials, what that means is they are preparing for those clinical trials simultaneously, as opposed to sequentially, so that at a certain point, they'll be able to jump into these clinical trials in a more rapid pace. It allows them to be able to gather volunteers, to be able to make sure they have people and the equipment and all of the things necessary in a much faster way. That does not necessarily mean that the data is going to be worse. They're still going to be doing clinical, well-controlled clinical trials. These are still going to be scientific trials.
Yeah, it's just the reason it's also not normally done is because it's riskier. It's sort of like running up the credit card because you're pretty sure you're going to get the promotion at work, but right. It's not even going to be decided till a month from now. And there are other contenders. So it's risky for everyone involved in terms of funding it and going forward with it and all of this. But yes, exactly what you just said. It doesn't actually affect the scientific method. resources that go into it.
And from resources, also money. So like you said, the analogy of running up the credit card ahead of time, that's exactly what's happening. Is the money that is needed to make these clinical trials happen is being made available. Whereas in normal situations, it might take a lot longer to get that money to make the trials happen. So it makes those resources available, which is very important. I think that's a really important point. And as Fauci said just yesterday in his testimony in front of Congress, he said, this is promising, but nothing is promised. So there is potential there, but he said, maybe by winter we'll be through phase 3 and have some inkling of whether or not it's actually going to work. But we need to remember there are 80 vaccines under development around the globe right now. I think this is the most exciting part of it, is that so many people are given the resources right now to work on so many different ideas. It's that diversification and resource allocation that is so important for science to actually move forward. And I think that is the most exciting part of this vaccine acceleration. And this moves me right into my next story, which comes on the heels of a Nature publication. Researchers published in Nature today a study looking at anti-vaccine spread on networks within Facebook. And this study was looking not at COVID, but it is very applicable to the situation that we are under today. They were specifically looking more at just where anti-vaccination groups are showing up in places like Facebook and how they are getting their messages out to the public. And what they're really finding is that the reach of the groups was really shocking. The first author, Neil Johnson, who's a professor of physics, who studies collective behavior on social media, he says, what we thought would be fringe is actually the core. His work is focused on measles, and he started looking at these online groups and found that that there are clusters of anti-vax groups that reach undecided people on Facebook. And because of the variety in the messaging that anti-vaccine groups use, they are much more able to reach out to the yoga moms, reach out to the very conservative people on Facebook. They're able to reach out to people who are afraid of corporations and pharmaceutical companies. They have a variety of messages, whereas what they found for the pro-vaccine groups is that the pro-vaccine groups are not as well spread because their messaging is much more limited. Their messaging is, hey, vaccines save lives. And so it's a much more, what they call it, it's very vanilla. The pro-vaccine groups are like, here's our vanilla ice cream. That's all we've got. But the anti-vaccine groups are like, look, I've got chocolate syrup.
I'm reminded of what's going on with climate change at messaging, and how maybe 10 years ago, maybe even less than that, actually, a lot of climate scientists out there had the understanding, we are scientists. We are not public relations personnel. Here is the data. The data will speak for itself. And we have learned that when you have truth on your side and scientific evidence and data, you have a tendency to want to say, like, well, there it is. Here's the situation. And when you are kind of creating a narrative, let's say, I think things get more flowery and more persuasive.
Well, that's the key word. It's manipulation versus messaging.
Mm-hmm.
Yeah.
But it's also important about what I really want to pinpoint here is the fact that the variety of different messages allow it to be framed in, it's like an all-you-can-eat buffet. You can, if there's something that appeals to you, you're going to find it in there. So maybe the anti-vaccine messaging about freedom, maybe that doesn't ring a bell with you, but maybe the anti-vaccine messaging about, the bad corporations who are, not thinking about us, they're thinking about, or the pharma companies that all they care about is money. Maybe that messaging works for you. So the variety of the messages basically allows that whatever hot button issue hits you emotionally to start to insert that sliver of doubt, to insert that question into your mind. Suddenly it's there. And so what they found when they did their network analysis is that the anti-vaccine groups are well distributed pretty much everywhere on these social media platforms. They looked at Facebook, so within Facebook, whereas the pro-vaccine groups were isolated comparatively and not even really interacting with the anti-vaccine groups for a large part. So a lot of the messaging that the pro-vaccine groups want to get out isn't even getting to the people that they want it to reach.
But don't you think part of that is because pro-vaxxer in and of itself is like a weird thing to say? Like that just means you're the standard, right? So that's almost like, if somebody's a nudist because they're going around telling everybody, but you're not going around going, I like to wear pants. Like, you know what I mean? So I just feel like there's a situation here where I'm not going on Facebook every day saying I'm pro-vaccine, right? Mm-hmm. But the people who are going against the establishment, if you want to look at it that way, they are going to be more vocal about moving from standard. So I also feel like people who you would want to consider pro-vaccine are probably very well connected, and that blob is probably way larger than this anti-vaxxer blob, but people aren't putting that information out there because it's a given.
Right. And so maybe that is part of the problem is who is talking about it, where and why, where you don't necessarily go out and talk about, putting on your pants in the morning. You don't do that. I mean, maybe now during COVID we do. You're like, I wear pants today, but maybe it's a different. But
we should when we go and get our flu shot, or when we go and get our TB test, or whenever we do any standard medicine. Maybe this means we need to share it.
And if you are in a social group that you see somebody spouting off with particular views, you need to address that and talk about not necessarily saying, I think you're wrong and attacking, but you need to address it and say, hey, I get vaccinated. Vaccinating's great because of blah. Just stay positive and state your case and counteract whatever you see out there in whichever places you see it. And I, in terms of the vaccines that are being developed now, I think that is part of the messaging that, I'm thinking that messaging needs to take into account the fact that they're talking about fast tracking and accelerating, and people go fast. Isn't that bad? You're not taking the time. Well, we need to start talking about the care that is being taken, the people who are working on these vaccines who care about saving lives. We need to talk about why the vaccines are being developed in a faster way, so that we can at least counteract a bit of the fear. I was thinking today that maybe, we've got the startup culture. It's you can pick 2 out of 3, either fast, cheap, or good. Which do you choose, right? So we've got the fast messaging out there already. Let's focus on the good, right? We need to talk about why this vaccine is so important. We need to work on that and talk about how much time and effort the scientists are putting into this.
Yeah. I mean, we talked about that a couple weeks ago. Science is having a moment, right?
Yep.
So how can we make sure to take advantage of that to kind of
but we're not going to. We're not going to engage. I'm serious. We're just not going to be able to engage in the way that you were describing the anti-vaxxers are engaging. Unless we started lying and manipulating people.
And I'm not going to do that.
Right. But this is the thing. You would have to say, you'd have to, instead of God will prevent you from getting a disease, you don't need this science government vaccine. We'd have to say, God sent 3 canoes to go pick up the guy off the roof who was praying to God. And when he finally drowned and went to heaven, God said, I sent you 3 canoes. I sent 3 boats. Why didn't you get on any of them?
Right.
What were you waiting for? That's what the vaccines are. I sent you vaccines. I put these ideas in the heads. We'd have to be talking like that. God has created vaccines through these scientists, using them as vessels for his will. And that's why they exist. You would have to be having the conversation like that. The only way to prevent
I've had conversations like that. My mom was Christian Scientist. She had multiple sclerosis. She didn't want to go to doctors. For about a decade, I had to convince my mom that going to doctors was a great idea because don't you think God would want us to be smart enough to try and fix ourselves?
But this isn't the conversation that responsible entities are willing to engage in. They're not going to tell, the preppers and the, anti-government preppers, like, the only way to keep the government from getting you sick and putting you in their healthcare system and taking advantage of you is to get vaccinated against the diseases they've been building in secret labs in foreign countries. Like, you would literally have to be talking to them on that insane level to try to manipulate them into, and nobody's going to do it. Nobody.
I don't want to.
This is also it's like the people.
I don't want to manipulate people. I want people to make the decision themselves, and that's that's difficult.
It's also like the whole problem with like people who are concerned about overpopulation, not wanting to have too many kids. That just means that less people who are concerned with it are going to be on the planet a generation from now. It's a winning battle to be ignorant. That's the thing. That's the big secret. It's a winning battle to be ignorant and to manipulate ignorant people. It's a winning battle.
I hope not. And I just want to take a minute talking about going against misinformation. Have you both of you heard of Plandemic?
Yes.
So a quote unquote documentary, I think they wanted to call it. It's called Propaganda, is what it is. There was a video that came out online this last week. It has since been taken down by YouTube and Facebook and Vimeo and other video platforms because of its peddling of misinformation. One of the key interviews in the video went on to say things like wearing a face mask actually would cause you to get infected because it activates the virus. Now, I want you all to know that is absolutely untrue, and there is no documentation anywhere that supports that claim. Wearing a face mask has only been shown to be helpful to your not spreading the disease. More for you not spreading it to others than for yourself not getting it. And the idea, if it is worn correctly, it must be worn correctly, and that is where it is right now. It's common courtesy and respect for other people. Yes. That is why you would want to wear a face mask. But the video itself had many items within itself that were entirely untrue or at least misrepresented. And there are several websites, NPR, Science, the AAAS Science news site, and others, Live Science, that have taken the time to do fact checks of Plandemic. So I do hope, if you have not seen Plandemic, that you will look out for one of the fact checks and not necessarily look out for the video itself. The goal of the video is unclear, but for the large part, it seeks to undermine the voices like Fauci's at the CDC that are working to save lives, that are working to bring us together, to try and get us to work together as a society to overcome this pandemic. And it seems to be a video that is looking to sow seeds of doubt with respect to vaccine. So I do hope that we all take this to our hearts, and when we go into the social media moving forward and see people say things that potentially came from that video, that we can address them with reason, with logic, and with care, because these are other people who just might be a little misguided and misinformed because they didn't get their information from the right place.
Yeah, I think it's definitely taken a turn where before there were definitely judgments, and I am not without blame there, of people doing things where I'm like, that's not right. But now it's at a point where there's actual misinformation getting fed out there.
Yeah.
So it's not even that people just didn't know better, it's that they're actually being actively misinformed. So it's taking a completely new turn.
Yep, it's
wild. It's wild.
It is. What? Why do you?
Sorry,
you got a phone call?
Hello? Yeah. It's Darwin. He still has my landline. I don't know.
Okay.
Okay. Oh, that's Darwin. He says, "Don't worry, he's got this. The problem will be corrected in time."
And while that is, I do appreciate that joke. The Darwin Awards are fantastic. I also don't like it because it means that other people who didn't, who were trying to be safe, who are trying to do things the best of ways, can still potentially be affected because of the thoughtlessness and disrespect of others. So
that's the real kicker, man, is it's not just the people who are ignoring the best efforts of everyone trying to keep people safe, is they could, wander into the hospital and get a loved one who works in a hospital sick.
I know. So let's all. It's
a very specific location. I don't know why.
Yeah.
We all have to do our part, and we all have to play our part. And this is a societal issue. And if you can help people understand how to do things better, then we should do that. And let's try to be good to each other, respect each other, wear masks, wash hands, and call out misinformation when we see it, because we don't need those slivers of doubt that are already there when a vaccine is finally available. And I'm going to say is, even though I know it might never come. I have that hope. I have that little bit of hope. All right. Let's move away from the misinformation and the COVID news of the week. Oh, yeah. Apparently there's another study that says cats might get COVID.
Oh, we've been knowing about that.
We know that. They looked at 3 cats this time.
Oh, okay.
A huge cats, sample size.
Mustelids, so weasels, and now they're saying pigs and pig relatives maybe also.
Yeah. In this new study, they found the cats could give it to each other. So cats can pass it to other, but it was a very small sample size. But in their sample set, cats passed it to other cats. And if cats can pass it to other cats, they can probably pass it to people. But we can't ethically do those experiments. So just know that maybe don't pet the neighborhood cat that's out there in your neighborhood when you're out for a walk wearing your mask. Or just make sure you wash your hands. Justin, do you have some science news?
From the journal Aging and Disease, which sounds like a type of periodical nobody subscribes to until pretty much it's too late.
Mm-hmm.
That's what. If you're subscribing to that, it's probably
my weekly articles have arrived.
Blair, you are not in the AARP listening to this yet. Come on.
Okay, so according to this, microRNAs play a big role in our bodies, controlling of gene expression. They're also the front line when it comes to an invading virus that they can latch onto and cut into the RNA of a virus. And the genetic material of the virus as well. This is Dr. Sadanand Fuzela, aging researcher in the Department of... They're not actually... The researcher is not that they're especially aged or aging any faster than the rest of us. They're an aging researcher in the Department of Medicine and Center for Healthy Aging at the Medical College of Georgia, Augusta University. With age, the study finds, and certain chronic medical conditions, the attacking microRNA numbers dwindle, reducing our ability to respond two viruses, says Dr. Carlos Isales of the Division of Endocrinology, Diabetes, and Metabolism. So they actually identified a number of microRNAs. They had samples of SARS, the 2002 version, and the SARS-CoV-2, which is the cause of the COVID-19. And they had the sequences of microRNAs that appeared to be attacking these viruses using computer simulations. They also had taken these samples, not just from one sort of group of people, but they had 29 samples that were from 17 countries, 5 continents. So they got a really nice grouping of this. They found 848 microRNAs that target the SARS genome, 873 microRNAs that target SARS-CoV-2. They found 558 microRNAs that will fight SARS and COVID-2, while there was 315 that were unique to the COVID-2. So what's sort of interesting, they also found 10 target sites that could be found through this simulation that would be the most proficient at fighting the virus. Very interesting. What's really kind of nice about this too is because they found these microRNAs in individuals from very far away, very disparate places, that shows that these microRNAs are not something from a local gene pool or something of this nature, but they seem to be pretty universal and have the ability to attack different points of the virus. So ultimately, they are trying to create what they think would be a sufficient trial to create microRNAs outside of the body and then introduce them in some ways, perhaps even the nose, according to this. But I think ultimately what this sort of research does is it will then inform also the community of people who are looking at ways to attack this virus with different attack points, different weaknesses, different strategies that they might employ. But also very interesting because there is a drop off of these microRNAs as we age, and if we've ever wondered why it is people who are older are more susceptible, this might be a pretty good clue. It might be. It's still correlation. Some mechanism involved at the basis of this as well, though.
Yeah, I mean, I wonder. And if it is the case that some of these microRNAs are reduced as you age, then maybe there's a way to increase them. Is there a treatment, a medication that could increase it? Make it,
yeah. So there. This is the quotey voice of Isaiah. He says, "My perspective is that there's a key set of microRNAs that are important in triggering this abnormal response and making older patients more susceptible. We're looking at microRNAs in general dropping, but there is a specific subset that is key. The question is whether we can target those as a therapy. If you can get somebody a cocktail of multiple key microRNAs that are potentially all attacking the virus, might be sufficient to kill the virus." Yeah.
That would be pretty awesome. Although we are seeing that there are some younger cases, these rare childhood cases that appear to have an inflammatory response, Kawasaki's disease and something else.
An intestinal reaction.
Pulmonary problems, yeah.
But I'm also seeing intestinal reactions. Like they are getting one of the first symptoms apparently that you're seeing in children isn't the coughing, is respiratory issues. Gut. But it's gut. It's like, yeah.
And I remember when this all started, they were saying like gut stuff, like probably not COVID then. You probably have just like the flu or something else.
But I guess children have increased ACE2 receptors in their intestines is somehow part of that. Anyway.
Yeah. It's so interesting. There's so many things that are, I mean, just really unknown that we have to learn.
Well, and as Justin's talked about before, this is like a reminder of how people look at science and how people who understand how science works see this versus how a person who's kind of more removed from the process sees it. And we see it as like, this is great. We're learning new things all the time. And somebody else can see it and go, they don't know what they're talking about. Those scientists. Like, oh, no, that's not how it works.
Yeah. No, it is. This is how it works. It's completely like this behind the curtain until everybody has been chasing down these null hypotheses until there's something left at the end. And then you go, we've got a pretty good lock on.
It's probably that. Yeah.
So this is, speaking of things that people may not know as much about as they thought they did, despite what your gynecologist might have told you, your lesions might be pretty common and actually completely benign. For years, researchers have become concerned about a possible link between gynecologic lesions called endosalpingosis, ES. And I was just taking a shot at it first time through. It's okay. We'll call it ES from here on out. So the link between ES and ovarian cancer. However, using a diagnostic method typically reserved for specimens suspicious for cancer, a team of researchers led by Baylor College of Medicine physician found the prevalence of ES and other gynecological lesions was substantially higher than ever previously reported or discovered among women without cancer. The high rate of occurrence led the researchers to believe that maybe there wasn't actually a link between lesions and cancers had been previously suspected. Now, one of the things that is true is that women who have ovarian cancer have higher rates of these lesions. However, they also have much more thorough examination.
Right.
And they're saying like, that might just be it. When they've done these studies that have shown correlation and linkages, they actually have never done the one where they've done that investigation on women who don't have cancer. So then what happens is you end up with this little bit of bias about what you're seeing and what that is linked to in the data. And so there are probably untold millions of women in the world who've been told, you have some lesions. It could end up being, it's benign now, but it could be cancer, who just have the whole, like the stress of that. Mm-hmm. When it turns out, it's actually, when I say common, you might think I'm saying a number like 10%, 20%. Now, this was, researchers found ES alone was in 37% of women, 31 to 50. 66% of women postmenopausal. 22%. Let's see, what was this? Prevalence. Yes. So after implementing their new protocol, the prevalence of ES increased from 2.5%, which is where it was before, to 22% in all specimens over the period. So basically what they have just discovered is that when doing science, you need that control group.
Yes.
Before you must have that control group in order to come to any conclusion.
Yep.
So your JJs are probably in much better shape than your gynecologist had thought.
Which is great news.
Yes.
I mean, potentially one less thing for the gynecologists to worry about and for you to worry about. But I think your point about control groups, and not just control groups, but if you can produce randomly assigned groups, whether it's control or test groups, that is really, really important to making these determinations about whether something is actually a sign of disease or whether it's a correlation, happenstance. And we're running into that a lot right now with COVID-19 studies, because many studies are happening on the fly in hospital wings when doctors are like, I'm just going to look at this. And they have 14 patients in their intensive care. And those are the only patients they look at.
Yeah.
Well, and not to mention that the asymptomatic people are avoiding hospitals.
Right.
And,
exactly.
And your medical doctors, your physicians, your hospital doctors, they have not been really involved in scientific research since 4 out of 5 of them recommended Camel cigarettes for a smoother throat flavor. Like they have not, but this is not what they do. This is not what they studied to do. It just isn't. It's
Unless
very
you're
different.
an MD PhD. If you're an MD PhD, you did study, you learned how to do the research. But medical doctors, no, they did not. They are technicians for the large part. Intelligent people, great. For sure. But yeah,
absolutely. But it's a different task. I mean, it's a
different skill.
It is. Yes.
They're not worried about double blinding what they're doing. They're trying
No,
to
they want to make
lives.
something work.
Yeah.
It's a completely different application case. Yeah.
Yeah.
Anyway, really great news to start this show off.
Isn't it?
This is This Week in Science. If you are just tuning in, and if you are interested in a TWIS shirt or a mug or other item of TWIS merchandise, head over to twis.org and click on our Zazzle link to browse the store. Blair just put some new items in there. New pillows and sweatshirts and wrapping paper. In case you need to give a fun gift. Lots of artwork. Great stuff in our Zazzle store if you want to take a look there. And now it's time for us to roll into that segment of the show that is full of Blair. Blair's Animal Corner.
With Blair.
She loves our creature, great and small. Biped, millipede, no pet at all. Wanna hear about animals? She's your girl. Except for giant pandas and squirrels.
What you got, Blair?
Well, I have an amazing story about mother sea turtles and an extra bit of care that they give to their babies before they leave them forever. So as we know, sea turtles, they will dig a nest and they will lay hundreds, if not more, eggs in this nest, cover it up with sand, and then go back to the sea. And after that, the babies, the eggs are incubated, they hatch, they crawl out of the sand, and they head to the water on their own. So the mother doesn't really give much in terms of parental care, except for in finding a nesting site and creating that nest. Which you already know is really important because the location can have a lot to do with how many predators there are, how close to water they are, and their temperature of the eggs inside the nest, which, as we've discussed before, is directly related to whether those turtles are hatched male or female, all based on the temperature of the nest where they are incubated. But now we know something else that sea turtle mothers do to take care of their eggs. This is a piece of research from University of Glasgow. And this is looking at leatherbacks and hawksbill sea turtles. And it turns out that when females cover their nest where they laid their eggs, they spend a whole bunch of extra time kind of shuffling around the beach. And it looks like they're scattering sand around the next site or next couple of sites before heading back to the ocean. Spending extra time on the beach is a lot of risk. It's exposure, it's exhaustion, predation, humans. There's lots of reasons to head to the ocean as quickly as you can after you deposit those eggs. Not to mention the fact that just your presence there could be an indication that there is a nest. So you could see how they would want to scoot as soon as possible back to the ocean. But they do this funny shuffling at what would be the next nest site. And when they closely followed the activity of these hawksbill and leatherback turtles, their findings support the idea that they are creating a decoy nest to reduce the likelihood that their nest will be dug up. So it's not that they're disguising or camouflaging the real nest, it's that they are making a decoy. So they spend this extra time out on the beach to try to beat the odds of someone disturbing the nest that they made. And when they looked into other turtle species, 2 other species, they found similar behavior. And those 2 other species actually are not super closely related to the hawksbill and the leatherback sea turtle. Their common ancestor is over 100 million years old. So they think that this could be potentially a highly conserved strategy across turtles.
So yeah, if you are you're going to you dig up 2 or 3 of these things that look like they might be nests and they aren't, it's probably time to give up. Yeah, brilliant.
Which is also interesting because there's actually a conservation project you can volunteer for, where you basically just hang out on a beach and in Costa Rica, and you're basically a turtle guard. You're just making sure that people aren't bothering the mother sea turtles. And it's because you don't want to disturb them while they're laying. But now you can see it's even more important that they don't get disturbed by humans in this process, because it's more than just laying eggs and covering the eggs up. It's about the secondary process of reducing the probability that those eggs will be predated upon by predators. So they really need to spend some time on that beach.
Who are the predators? Are they birds? Are they other just beach dwelling reptiles?
Yeah, I mean it depends on the turtle and what's where they are there, but yeah, mostly birds, but depending where you're at, if there are any sort of crocodilians or anything like that, they would definitely go for it. Reptiles for sure. Yeah. I haven't heard of a lot of mammals going for turtle eggs, but I could be wrong about that.
I wonder if there's a difference right now in their behavior this year because there are no people around.
It's interesting you should mention that, and there is. They already found that the nesting beaches are much more peaceful and the leatherbacks are nesting much better.
So overall, the whole process is easier and better.
Yeah. Just yet another species. It's like, finally, a break.
Yeah, there are stories all over about all the baby sea turtles making their way off of the beaches this year. It's going to be a bumper year for the sea turtle population.
That's great because it takes them like 50 years or something to be sexually mature. So
are they just the ultimate nature over nurture? Like, when do they get to see another turtle? When do they hang out with turtles again? Like,
takes a while.
How do they know anything?
They just water's over there.
They just know.
It's so amazing.
Yeah. It is real. That's really amazing. Yeah, and Mama is not there to tell them how to do it. Mama's like, I laid you. I protected you. I shuffled around. I waved my flippers and threw sand around. I tried to...
Did my part.
Don't
look over here. Look over here. It's like the ultimate misdirection of a magician.
Exactly.
You were watching this hand, but you should have been watching this hand.
Yes. My nest is not under that flipper. Under this one.
Well,
what else do you have?
Speaking of babies, I know a lot of people have been adopting puppies since everyone's stuck at home, and I adopted a puppy just in time last November.
Yes, you did.
And a study came out that really it hit home. So I wanted to share my experience. So this is from Newcastle University and University of Nottingham. Can't say it any other way. I have to say Nottingham.
Nottingham.
This is about adolescence in dogs. So before I am going to say what scientifically occurred here in this study, I will say that my puppy has been very, very smart. She was the best in her class. She was learning tricks really well. And a couple of months ago, she just kind of started acting, I'm not going to say defiant, but just like you would ask her to do something and she just kind of stare at you and walk away. Like, I know you know how to do this. What's going on here? And then other times she would do it, and then she would do other things, but not the most simple tasks. And I kept joking that she was an angsty teenager. Well, This study is looking at adolescent behavior in dogs, and that dogs were more likely to ignore commands given by their caregiver, and they were harder to train at approximately the age of 8 months when they are going through puberty or in their quote unquote teenage years. So right away, I was thinking, oh my gosh, I just experienced this. And it's also more pronounced in dogs that have an insecure attachment to their owner, which right now, everybody, all the animals do because everyone's home all the time.
Oh,
so
that's true. Yeah.
That is an additional piece here. And kind of why this is relevant and isn't just like, oh yeah, dogs are people too sort of story, is that actually adolescence is a time when puppies that were adopted or purchased are dropped off en masse to shelters. Lots of dogs get rehomed between 8 and 12 months. And we usually think like, oh, it's just because they're not cute puppies anymore. But this is taking it to a whole nother level. So suddenly, if it's not just that they're not a cute puppy anymore, but also that they're ignoring commands or they're quote unquote difficult to train or a more challenging dog, it's just because they're teenagers and that phase is actually likely to pass. So if you know this going in and you could push through to the year mark with this dog, if you're having trouble,
it might be better.
Yeah, some of these problems might go away, which if you know that as a new dog owner, that can completely change that dog's life if it's not rehomed at that time. Because also keep in mind that if this dog is already going through behavior issues and has an insecure attachment to their owner, and now they're being dropped off at the shelter, that can have a lifelong implication. So it can like feed itself, right? So the initial study was with a group of 69 dogs, and they monitored obedience in them. It was just Labradors and Golden Retrievers for this initial study. And they also looked at crossbreeds of the two. They looked at them from ages of 5 months, which is before adolescence, and 8 months during adolescence. What I think is so interesting is that they took longer to respond to the sit command, which was exactly the one Sadie knows how to do. All this stuff. She knows how to shake. She knows down, she knows come, she knows touch, she knows all these different things. And for some reason, I would ask her to sit. She'd just kind of be like, nope. So specifically, the sit command, they would take longer to respond, but only when the command was given by a caregiver, not a stranger. If a stranger walked into the room and said sit, they did it right away.
This sounds like what I'm going through with my 9-year-old child.
Yeah. So the odds of repeatedly not responding to that sit command from their caregiver were higher at 8 months compared to 5 months. And then they did an additional test with 285 dogs. The owners and a trainer less familiar with each dog filled in a questionnaire looking at trainability. So they asked them to do a bunch of stuff. Things like, do they refuse to obey commands? Do they refuse to obey commands which in the past they have learned? Do they respond immediately to a recall command when they're off lead? And the caregivers gave lower scores of trainability to dogs that were in adolescence. But the trainers actually had an increased trainability score between 5 and 8 months. So it really is a behavior choice to ignore the request of their caregiver.
Oh, adolescence. I'm not going to do what you say. I'm going to do what I want.
And this is where they bring up kind of what you talked about, that this is something that we see paralleled in parent-child relationship, and that it's, this conflict could be similar between a dog's primary caregiver and the dog, which also means that it's really important that you don't give up on the dog in this difficult time, like I mentioned, but also that you don't punish the dog for disobedience or start to, they say, pull away emotionally, because that can actually make it worse. It's like when you punish a teenager for acting out and then it snowballs, right?
Oh my gosh.
So it's just it's very interesting to see that in dogs in a way that we can really quantify, and in a way that resonated with me so strongly is very interesting. But now, of course, I can't help but wonder what other animals are going through this. We can measure it because we are asking things of these dogs. So the dogs have relationships with us that we can measure. But if we start to look at
I bet you
a
parrots.
troop of monkeys or a group of parrots,
Mhm.
do you see similar things happening with what you would consider an adolescent individual ignoring desires of others?
Oh, I think that's probably absolutely in the ape world. I'm sure
And-
that's
Oh
like,
yeah.
well done.
Oh yeah.
And not just, but like you said, though, not just the desires of others, the desires of those they are attached to.
Hmm.
Because this is a step I'm going to take towards my own independence, toward deciding to do this, whether or not you've
Mhm.
told me to do it.
Right. Right.
And it's probably hormonal, you know. I don't know. I mean, I like to say that my 9-year-old child, you know, he has the cognitive ability to defy. But, you know, for a dog, do they have that sense of mind to
Mhm.
be defiant in that way? Or is it just hormones making them do what they're going to do?
Right. Or
It's
is
so
it
interesting.
hormones making them defiant?
Exactly. And
Could
how
be
does
all of
that
it.
work? How
Yeah.
does that work? Oh, I love it. Defiance. Oh, so fascinating. Thanks for giving us that little angsty story.
Yeah.
I'm
Absolutely.
glad I don't have a dog.
I will report that now that Sadie is 10 months,
Is it getting
she
better?
is starting to come out of it. She is better than she was a month ago. Very interesting.
Keep us updated.
Oh,
Let
I
us
will.
know how it goes.
will.
I would love to know. All right, everybody. I'm going to do a little music right now because I think Justin went away. I would love you to know that this is This Week in Science, and I want to say thank you for listening to TWIS. You are the reason that we're able to do this every single week, that we can come here and talk about science and share with you and talk with you. It's all because of you. And if you, with your help, if you help us out, we can really do more. We can grow this show. We can tell more people about curiosity, build curiosity, talk about science and what is knowledge? What is scientific method? How do we do all this? We can talk about these things. We can combat misinformation with you. So head over to twist.org right now if you haven't already done it. Click on the Patreon link and choose to be a patron of TWIS. Choose your own level of support and be a part of bringing sanity and science to more people.
And we're back. You're listening to This Week in Science.
Yeah, we have more science for you. That's right. If you have a What Has Science Done For Me lately story or another kind of question or comment about stuff, be sure to reach out to us. My email is Kirsten, Kirsten, at thisweekinscience.com. And we will do what we can to answer your questions and also read your letters on the show. I have chimeras. I do. There's a cool chimera story. I'm always one for chimeras. I really love bringing them into the show. I've talked before about efforts by researchers to meld human cells with other animals, and there has been research to get human stem cells to incorporate into the embryos of pigs and sheep and monkeys and mice. And now there is a new study that is out of, let's make sure I know exactly where they are from. I think it is from University of southwestern Texas is where these researchers are working. Yeah, University of Texas Southwestern Medical Center in Dallas. And the researchers who just published their research in Science Advances, have used a new method to incorporate human stem cells into animal embryos. They used mice in this particular situation, and they did what they call resetting the clock on the human cells to get them to combine a little better with the mouse cells. So they took human stem cells and they reverted them back to a pluripotent state, to a state where these cells would potentially not even remember their identity. Who cares if I'm human? Whatever. And then they affected a protein called mTOR. And mTOR is a clock protein. It's related to the setting of our circadian clocks, and it's how our cells kind of coordinate with each other and have synchronized timings so that things like cellular development can take place at a particular pace of time. They affected the human cells to make them more useful and injected these cells into batches of about 10 or 12 of these stem cells into mouse embryos that only had about 60 to 80 mouse cells, so they were at a very early stage of their mousy development, really, really early on in their division, about 14 days after fertilization. They were, by doing this, able to increase the amount of human cells that survived within the mouse tissues from the small numbers that have previously been seen in other studies with chimeras with different species to between 0.1 and 4% of the total cells in the embryos. And while that doesn't seem like a lot, when it comes to the number of cells, we're talking millions of cells now, as opposed to hundreds or tens of thousands. So what they have been able to do by essentially making the human stem cells forget who they were and forget what day it was, those cells could then take the instructions of the surrounding mouse embryo cells and start to develop more like mouse cells than human cells. And that's kind of what this study shows, is that these cells that are in the mouse embryo, they incorporated in a way that they didn't try to stay human. They kind of tried to do mousy things. They took the mouse instructions, so microRNAs, messenger RNAs, signaling proteins, things that would be the bath of development in a mouse embryo. And the human cells, it didn't matter. They're like, I'm just going to do what the mouse embryo tells me to do.
There was an interesting story that we didn't ever get to because I read it and I didn't get it, and then time passed. But it was the researchers are trying to explain that, and I think we talked about it in an after show once about a researcher who's like, the genetic code is more ingredients than it is building instructions. That the actual work of what does what happens at the tissue level. And I think this is kind of a fascinating example of that. It's like, yeah, we put in different ingredients, but the tissues were like, no, we're going to put this over here. That's not how that goes together. That's going to go together like this. And it's actually tissue communication that does a lot of the things that, you can trace it back to DNA to a great degree of using the right ingredients, but it's actually the construction taking place on a level above that code, which is a really fascinating thing. Which I read the paper, I totally couldn't quite understand, but it does tell us that there is much more to.
Yeah, well, if you think about with human development, it's okay. There is an instruction, a little piece of messenger RNA that, or microRNA, most likely, that goes to another location in the DNA, right? And says, okay, we want some of this protein right now. And so this gene needs to get translated. And the amount of the microRNA is going to be responsible for how much of that protein, the gene, gets translated and transcribed into a protein. And so these instructions kind of say, we want this much bone, we want this much cartilage, versus we want extra, we want less. And so it's those little control factors that are a big part of making us unique to our species. There are genetic differences, certainly, but these mice, apparently in this study, they apparently grew normally. The human cells incorporated themselves. But the one thing that is interesting is they did not find any evidence of sperm or eggs in the mice incorporating human DNA or human cells. So there were no, in the sperm, there were no, well, look, I'm a human sperm. In the eggs, there were no, look, I'm a human egg. Like there was
How did I end up here?
Yeah, there was none of that. It was all mouse. Right. So these chimeric mice aren't necessarily, well, they're research mice. They're not going to go on and reproduce anyway, but they're not necessarily going to go on and reproduce mouse-human hybrid chimeric animals. There's not an issue with that at this point. Yeah, so it's a very interesting question whether this affecting the clock genes, not just, okay, you're a human cell and we're sticking you in another animal, but I'm going to spin. It's basically the equivalent of pin the tail on the donkey, or one of those children's games where you put somebody in a blindfold and spin them around in circles. And then, take the blindfold off and go see where you get, or, it's the equivalent of, just really, it's really messing up the clock cells, messes up the cell's ability to understand where it is and what it's supposed to be doing. And so the only thing it then knows is the instructions it's getting from outside of itself. And those instructions being all mouse, it's going to say, oh, okay, I guess I'm a mouse. Yeah. It's very interesting. We'll see if this goes further in other species, with other chimeras and other things. I don't know. Who knows where it'll go?
So we've talked quite a bit on this show in the past about global warming. But this is a story about global cooling. Actually, it's about the glacial maximum that we had 40,000-ish years ago. Fun fact: when we talk about global warming, we're talking about the sea level rise quite a bit. Do you know how much lower the oceans were 40,000 years ago ish during the glacial maximum?
No, but I bet they're underwater now.
410 feet.
What?
That is the sea level change since that glacial maximum. 410 feet. So thankfully, a lot of the melting's already been done. So the rest of the melting to come isn't going to be as impressive. We may only have sea level rise of some 30, 40, 50 feet. But it still seems like a lot because we all live by the coast. And that's not new. We've always lived by the coast. Oceans have been rising for thousands of years to some degree or another. This current research paper is published in Geographical Review, and they looked at that thing that's one of my favorite subjects, which is they played with maps and understanding of what's going on under the sea to try to figure out how people moved around and migrated at what they call choke points, which is actually the paper's called choke points. They're looking at the narrow land corridors that connect larger bodies of land across waters at that period, 20,000 years ago and further, to see where else we should be looking for human migration paths as well as civilizations. So one of the things that they did, so they dialed all of this back and they created their new map. One of the things that jumped out at them was in Alaska, in the Bering Strait. Turns out the Bering Strait, if you drop the sea level that much and you look at how things have changed over this time and dial everything back, was littered with islands in between. And the islands sort of started first appearing on the eastern part, the western part of that strait, and then sort of started popping up further and further and further to the west. So that if you were in the Siberia side, at some point there was an island visible out there off the coast. And if you managed to get on a little bit of boat and get out to this little reachable island that you could see, or you could see another island a little bit further east. And if you went there, you could see another and another and another. And so it sort of may not have been completely walking across, but it might have been island hopping all the way over, which is a really sort of fascinating thing because one of the things that we've sort of come to learn is that a large part of the native population in the Americas shows up very early in South America. There is some evidence of the oldest being somewhere up in that cave in the Yukon, maybe 25,000 years ago. A lot of the population then waits until the glaciers melt, but there's a population that seems to show up very early in South America, which means they may have had boats to hop across those islands and also continue to take them down the coast. So it's opening up some interesting stuff there. They also kind of pointed out, this is a quote from one of the researchers, Dobson. Who is Dobson? Jerry Dobson, professor emeritus of geography at the University of Kansas, who's one of the authors of the story. Look at these same choke points today. And they looked at 9 global choke points. They had the Bering Strait, they had Panama, Bosporus, I don't even know where that is. Dardanelles, I don't know. Strait of Gibraltar, Straits of Sicily and Messina, Suez, Hormuz Strait. Like I said, they looked at a lot of these different choke points around the world and dialed them back. Because it says, look at these same choke points today. Watch the nightly news. They're centers of ongoing conflict. Notice how the Strait of Hormuz controls the international flow of oil and sparks conflicts. Suez Canal and the role it played in the Suez Crisis of 1956 and the Six-Day War of 1967. Choke points, particularly straits, are pivotal to conflicts. Some of the other interesting things that they found, also Bering, Sicily, and created almost a separate sea from the Mediterranean. And they have found in the past a 39-foot long carved monolith that's 130 feet deep in those waters. So, and they suspect that was about a 10,000 year ago occupation. They're looking at how a lot of the Black Sea was landlocked and didn't really, it wasn't that big. So there's a huge potential for there being a large civilization somewhere underneath the Black Sea because of where it was located. It was a key migration point. And so there was very likely cultures and societies that had taken up residence there. But yes, they don't find the boats for a lot of this because, Australia probably required boats to get to it. Even when they dial this back, Australia isn't a place you can just walk to. But of course, boats are tough in the archaeological record in the first place because presumably they're going to be made out of wood. And if the boats were left on shorelines that are 400 feet underwater now and have been moving and eroding and everything, all the other processes that go on, it's probably pretty hard to find. But it makes that fantastic argument for underwater archaeology to be something that people should be doing. And my last story.
You're going ahead. What? Okay, you got it.
Am I?
You go.
Am I going? I think it shows up next on my thing here.
Okay, go for it.
We may have different rundowns. It's possible. Do you think you could outrun a T-Rex?
Absolutely not.
Yes.
If I had a boat.
If you had a boat, you might have a shot. Yeah. So scientists have generally assumed that long-limbed dinosaurs evolved to be speedy and catch up to prey, as well as to avoid predators. This is a story at University of Maryland's Thomas Holtz and colleagues suggest that long legs evolved among the biggest dinosaurs so that they could take longer steps and conserve energy. This is published in the journal PLOS One today. But when they looked at it, when they did put the size of T-Rex together with how much energy it would take to actually run and the mechanics that would be involved, you're like, no, he was not a runner. It looks like T-Rex was a long distance walker, built for taking long strides, conserving energy, and not chasing things. Which
like a vulture.
Something,
yeah.
That's exactly what you had pointed out earlier and have pointed out in the past.
Yeah.
Just slowly wandering around looking for dead things and scaring off anything else that might have, you can picture a bunch of velociraptors, which I guess didn't even hunt in packs, but taking down some prey on the dinosaur savannas or whatever they live. I still can't picture where a dinosaur lived. I have no idea. And then just chasing off the thing that actually ran fast and hunted something because it's big and scary, and just walking up and then taking over the meal that's already been killed. That's probably how T-Rex functions. Just being big, not needing to be fast.
I think what's interesting is I was just trying to look for images of T-Rex, but came across back in 2017, apparently there was a study that came out suggesting that T-Rex couldn't have run, that it was so big and its long legs were long, but if it had run, the mechanics would have broken its legs.
Because he was so heavy?
Yeah, that T-Rex would be heavy, even with those little arms. And then there was a more recent study that said that teenage T-Rex went through growth spurts. So could you imagine the growing pains and not being able to run and having to just walk away from any predators who are after you as a teenager? You're like,
and not sitting when your owner tells you to sit.
What? So what I'm kind of curious though, because they are looking. This is a conversation that they've done here is about a full-grown T-Rex. I wonder if the youngins actually could move around quite a bit, because until you get to a certain weight ratio, those long legs might have allowed them to be quick, which then could be used to actually run away from prey, which is what they would have needed it for. Until they got big enough not to have to run anymore.
And then they turn around and go, and then they'd have the big jaw.
I'm an apex scavenger.
Yep.
And not having to run. Thank goodness. Thank goodness.
I mean, hyenas are like that. You don't mess with hyenas. They don't do a lot of hunting. Usually just steal other animals' kills.
I would stay away from hyenas if I were to come face to face with them, which I haven't. Who knows? Maybe someday. Speaking of things that might have happened, could happen one day. Well, people, we like to talk about our self-control, right? We're humans. I have self-control. We've talked about the marshmallow experiment many times on this show.
Which is that's not self-control though. That's the whole point of this. We're always talking about it. That's a strategy.
But it's an example that people use to talk about self-control. Self-control though is
that's where we try to fix it.
Right. But we talk about also that teenagers don't necessarily have self-control, because self-control is regulated by the prefrontal cortex, which is one of the last areas of the brain to develop. Now, this new study doesn't talk about that, but it is particularly interesting because these researchers from the University of York started looking at 500,000-year-old flint axes that had been unearthed in West Sussex in the village of Boxgrove. And the axes have really great craftsmanship, and that they would have taken individuals' training and patience and self-control, having to forego immediacy in favor of long-term goals in order to sit and carve these flint axes. And so these researchers argue that because there are such finely crafted hand axes from 500,000 years ago, that's probably about when we got self-control.
Many years ago. That's too many years ago. That's too many years ago. No. 5,000 years ago.
500,000-year-old flint axes.
500,000-year-old where?
Yes, in Sussex.
I'm no archaeologist.
This is Neanderthals?
This is old, yes.
I have many questions. But
okay.
I'm very curious about the leap here from being able to make an intricate item to that meaning self-control.
Because I thought that's why I wanted to bring the study up. Yeah.
Do we know they did it all in one sitting? Or could they have used this thing and decorated it over time? Because that's not necessarily self-control. That's just prettying the thing you're using. That's like me doodling on the page that I'm taking notes on. It's not, you know what I mean? It's I don't see it foregoing use if it's something that could be done over a period of time. I also feel like self-control and discipline are different things.
Not necessarily, because even you to stick through discipline, even though it's training, it is still, you are controlling your own actions. The idea is that you are using your cognitive powers to decide on, as I said, more long-term goals as opposed to short-term gains. So you could get up right now with a rock. Look, I found this rock. I could get up with this rock and go try to find a rabbit to hit it on the head, or I can hunt for berries. Forget these rocks. Who needs them? I'm going to go look for herbs and berries. Or you can say to yourself, I would like to catch more things. I would like to do certain tasks. I have something I want to do. I'm going to sit with this rock and I'm going to take this piece of flint and I'm going to carve it. I'm going to sit and I'm going to carve it and turn it into something that's useful, that will have benefit to me in the future. So the planning, the long-term planning that goes into the action, and it inherently argues a level of cognitive ability that is above and beyond, a cat chasing a mouse or, other animalistic behaviors.
Well, Neanderthals also, this was, I should go find this story and put it in here because I think it's this week. Selected bovine ribs, even though they caught more deer. They didn't use deer ribs. They would wait until they got a cattle rib bone to use for scraping leather because it was much more durable and handy. So, I mean, the idea that here's the thing: technology that we have today versus technology then does not by itself infer a greater cognitive ability now than then. It just means that we've had more technology and a lot more humans sharing and interacting and thinking about things. One of the I guess things that we tend to do is think upon the past as though it was primitive in thought. And there's not really any evidence for it whatsoever. Now, what is interesting, though, is that a lot of these technologies, like this 500,000-year-old, the axes with the care, probably were not very different than the ones that were 300,000. Probably not too different than ones that they can find that are 700,000. What that means is they have been able to pass down information and teach the finally stepwise process of manufacturing one of these things for 100,000 years, which means they had to be good teachers and communicators. And for us to think that they did this with just like, watch me do it and repeat. No, there was language. Once you start getting into teaching a stepwise process, there's going to be language involved. And what's also interesting is there's places where like humans and Neanderthals overlap, or Neanderthal and Homo erectus. And you see shared technologies emerging where they're both making things in a similar way, which means they also cross-culturally had to be able to communicate and transfer that information to each other. We underestimate the past all the time.
Yeah, and I think that's what this study it gets at a bit, is the idea that we think we're special now, and self-control and our ability to plan for the future, and I'm going to save for college, or I'm planning for retirement, or I'm going to go on a vacation, or I'm just not going to eat today because I'm trying to lose weight to wear that dress. Like all these things that we plan for that we think are so impressive as human beings. 500,000 years ago, symmetrical, elaborate hand axes took probably a lifetime of skill to develop the knowledge, to transfer it to other individuals. This is an example of so much more going on within humanity 500,000 years ago.
And also just key point here, the knowledge that was required to live then and there was a knowledge of your ecology, your biome. You had to understand the movement of animals, the seasons and where you were going to find them, where the plants grew, what you could eat, what you couldn't eat. You required an incredible amount of knowledge to survive as a human, especially once you start talking about moving into climates where, there aren't. Neanderthals had survived in Europe for 500,000 years.
Let's talk about going back even further. Homo erectus had simple hand axes almost 2 million years ago. So if we're looking at these hand axes from 500,000 years ago as examples of self-control and planning and cognitive development, somebody taught those 500,000-year-old humans how to make axes. And so there was probably a lot more going on a lot further back.
Yeah, there's a couple
more places.
Like 2.5 million years ago, we see this version of axe, and 1 million years later, it gets kind of updated with this new kind of technology after that.
Yeah.
But it had to get transmitted down every time. You look at Homo floresiensis, and tools that are there are very similar to the ones that the humans started using when they arrived in Indonesia. So was there communication? Was there a sharing of knowledge that took place there as well? We underestimate the past because we are all so brilliant now. Have you looked around? Well, but yeah. Yes.
Well, crows use tools and crows store their tools. So
wait. But
this is the end of the show. You aren't so brilliant. No,
I'll spit it out one last little tidbit there too. Is like it could have been an intelligence that was like Leonardo da Vinci or an Einstein that came up with a couple of these first chord axes or cutting tools, or put the little eyelet in the thing that made it so they could thread something together. It may have been somebody of very elite intelligence that today would be what we would consider a genius, right?
Just different times, just different time and technology.
Working with what you got. And what's amazing is that their technology was so impactful that it became a necessity. And so they would dedicate time of teaching and passing that on from generation to generation, as we do now with things that we know to be core to our survival, and pass them on to the next generation.
Now I want to see documentaries that portray Einstein as a ancient human. No.
So they remake that caveman TV show, but with geniuses.
That's right, with geniuses, caveman geniuses. We are at the end of the show. Let's get some quick stories in here before we close it up. It's nighttime where I am right now, and in the night, you turn on your light, especially in the summer months, and you're going to see those moths fly up to your light, those nocturnal insects. What are they doing out there? What are they doing? I mean, they're not as colorful and fancy as the daytime insects who are pollinators and all over the place, transferring pollen from one place to another, pollinating the flowers. Daytime, wow, they're way more important. No, they're not. A study that's out this week said, hey, everybody's looking too much at daytime species. Let's look at the nighttime. And so they looked at nocturnal pollinators and found that they are a very important influence on the pollen transportation for wildflowers and actually contribute to complementary pollination paths in ecosystems that are less frequented by the daytime species. And so it is essential for ecosystem supports that we focus not just on the honeybees, which can potentially be negative if you only focus on the honeybees. It can be a negative impact on other pollinators, but take a holistic look at all the pollinators and don't forget about the nighttime gardens. The pollinators are at night. They're important and they do a lot. Don't kill all the nighttime bugs. We need them.
Bats
Unless
are pollinators too.
Right, bat pollinators, but that's mammal. I was talking about insects.
Yeah. But I'm just saying there's lots going on at night.
There's a lot happening at night.
We're just asleep, so we're not looking.
Yeah, and they found in hawk moths and other nighttime moth pollinators that they don't carry the pollen in the same way, that actually they tend to carry it on their thorax, that they climb in the plants in a different way and interact with the pollen, not quite in the same way as the daytime pollinators.
I'm picturing a moth getting into a flower like a kind of overweight older man getting into a hot tub. Like, oh yeah.
Rolling around in it. That's good.
Yeah.
I like it. I will never look at moths the same again. Thank you for that. What you got, Blair?
I just pictured their antenna as a comb over. Anyway, does everyone know about the Tully monster?
Tell us.
Is this like a Loch Ness type thing?
No.
I don't know what this is.
This is a fossil. This is from approximately 300 million years ago. Kiki, if you could share a picture, that would be great. And if you're listening to this audio only, Google it. Look up what a Tully monster looks like, because for this story to be as cool as it is, you have to see what this thing looks like. I was trying to describe it as a mixture between like a gharial, a squid, and a muppet. So anyway, Tully monster.
Yeah. Yes.
It's Tully monstrum gregarium. Was discovered in 1958 in Illinois, and as I said, from about 300 million years ago. And it's about the size of a bowling pin. And researchers to this point have not reached a consensus on whether or not this animal has a backbone. Now, looking at it, it looks kind of like a squid, so you might think it's an invertebrate, but then it also kind of has this jawed mouth, which makes it look like maybe it could be a vertebrate. My money definitely would have been on invertebrate based on its overall body plan. But a new piece of evidence indicates they do in fact think that this guy had a backbone. They did a microspectroscopy study and looked for either chitin or keratin. So if they had chitin somewhere in their body plan, likely that would be an invertebrate. That's what makes the exoskeleton of most invertebrates that have an exoskeleton. But it's somewhere in the body of an invertebrate in most cases. And then keratin is the stuff that we have all over our bodies, our nails, our hair. It's collagen. It's everything that's kind of like a harder structure that our body makes. Chances are it's keratin. So
It's
they're
my fingernails.
so they're unique enough that by just trying to find a trace of either of these things, since they couldn't find any actual bones, they felt like they could make a pretty good guess. And so this study did in fact find keratin makes them look like they likely have a backbone.
All right.
So this crazy thing is probably a vertebrate.
Wow.
The vertebrate Tully monster.
Yeah.
Less like
so
a
that's
squid.
a cousin. Yeah, it's one of our cousins.
Ah.
Cousin
yeah, that would
Tully.
make it. It's a more recent cousin as opposed to an older cousin.
Yeah.
Swimming in the Carboniferous seas. I don't know. There's something about the way that the image of the Tully monster looks, where its eyes are way, way back on its back, like a squid.
Yes.
And then it has this long beaked appendage at the front that looks like an arm. It's like an arm with a crab claw, but that's its mouth. It's very odd.
Yes, with a bellows on the back.
Yes. This is
Yeah,
an odd
it looks more like
creature.
a flamingo to me. Like if
Well, that's
if you got rid of the legs and the wings and the feathers and put the eyes in a weird place, it's a flamingo. Yeah.
And put spiky teeth in the flamingo mouth. Yes, there we go. Oh, I'm never.
Looks like something went horribly wrong with assembly for sure.
I will now be afraid of flamingos.
According to this, though, we're missing some parts.
Mm-hmm.
So
time will tell.
Yeah. So maybe, if you took half your parts away, you'd look pretty odd too.
Yeah, that's fair. He'd be missing most of its body.
Trying to reconstruct a human without the bones. They seem to be like puddle-like when they moved around.
Yeah. Thunder Beaver in the chat room says must have come with IKEA instructions. Yes, I think the Allen wrench was included.
Oh, nature, you never cease to surprise us with all the various forms. I mean, if this is the kind of thing that Earth biology could have come up with in the past, I can't wait to go to other planets. Come on. It's going to be great. Exciting stuff out there. So much variety. New ingredients. Are we done? Did we do it?
I think we performed a show.
We did. We have performed a show. Da, da. Thank you for listening. I really do hope that you enjoyed the show. And if you did, please share it with a friend. And for those of you out there listening, it's time for the shout outs. Fada, thank you for your help on social media and with show notes. Much appreciated. Gord, thank you for manning the chat room and keeping it going over there. ID4, thank you for recording the show. I would also like to thank the Burroughs Welcome Fund and our Patreon sponsors for their generous support. Thank you to Paul Disney, Andrew Swanson, Stu Pollock, Ed Dyer, Ken Hayes, Greg Landon, Tony Steele, Alex Wilson, Steve DeBell, Joshua Fury, Philip Shane, Ed Loves Science, Mark Mazzaros, Richard Porter, Sky Luke, Brian Condren, Richard, Eric Knapp, Bill K., Jason Roberts, Matthew Litwin, Jack, Bob Calder, Dave Neighbor, E.O., Kevin Parachan, Matt Sutter, Aaron Luthen, Flying Out, Christopher Rappin, Brendan Minish, Greg Briggs, Robert, Gary S., Marjorie, Rudy Garcia, Kurt Larson, Steve Leisman, Sean Lamb, Greg Riley, Jim Drapeau, Lisa Slazewski, Christopher Dreyer, Brian Carrington, Jason Olds, John McKee, Paul Artyom, Ulysses Adkins, Kevin Reardon, Noodles, Dave Wilkinson, Sue Doster, Paul Ronovich, Daryl Myshak, Dive Friedel, John Ratnaswamy, Stephen Alberon, Seth Gradney, Mountain Sloth, Rodney Lewis, Sarah Chavis, Corinne Bentons, John Gridley, Jean Tellier, Patrick Pecoraro, Darwin Hannon, Matt Bass, Dan K., Sarah Forfar, Darnold Mundus, Howard Tan, Josiah Zahner, Taylor P.S., Ben Bignell, Maddie Perrin, Ashley Doyle, Mark Hessenflow, John Atwood, Ali Coffin, Ben Rothig, John Lee. Thank you for all of your support on Patreon. And if you are interested in supporting us, you can find information at patreon.com/thisweekinscience. On next week's show,
we will be back Wednesday, 8 p.m. Pacific time, broadcasting live from our YouTube and Facebook channels, as well as from our headquarters at twis.org/live.
Hey, do you want to listen to us as a podcast? Just search for This Week in Science wherever you get podcasts from. If you enjoyed the show, get your friends to subscribe too.
For more information on anything you've heard here today, show notes and links to stories will be available on our website, which is www.TWIS.org. And you can also sign up for our newsletter there.
You can also contact us directly. Email Kirsten at kirsten@thisweekinscience.com, Justin at twistminion@gmail.com, or me, Blair, at blairbaz@twist.org. Just be sure to put TWIS, TWIS, in that subject line, or we'll never see it, because it will be spam filtered into oblivion.
Pew, pew, pew. You can also hit us up on the Twitter, where we are at Twist Science, at Dr. Kiki, at Jacksonfly, and at Blair's Menagerie. We love your feedback. If there's a topic you'd like us to cover or address, a suggestion for an interview, a haiku that comes to you tonight, please let us know.
We'll be back here next week, and we hope you'll join us again for more great science news.
And if you learned anything from the show, remember,
it's all in your head.
This Week in Science. This Week in Science. This Week in Science. This Week in Science, it's the end of the world. So I'm setting up shop, got my banner unfurled. It says the scientist is in, I'm gonna sell my advice. Show them how to stop the robots with a simple device. I'll reverse global warming with a wave of my hand. And all it'll cost you is a couple of grand. 'Cause this week's science is coming your way. So everybody listen to what I say. I use the scientific method for all that it's worth, and I'll broadcast my opinion all over the earth. 'Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in Science. This Week in Science. 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 I've got one disclaimer, and it shouldn't be news, that what I say may not represent your views, but I've done the calculations and I've got a plan. If you listen to the science, you may just yet understand that we're not trying to threaten your philosophy. We're just trying to save the world from jeopardy. Jeopardy. And This Week in Science is coming your way. So everybody listen to everything we say, and if you use our method instead of rolling a die, we may rid the world of toxoplasma gondii. 'Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in Science. This Week in Science. 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 Got a laundry list of items I want to address, from stopping global hunger to dredging Loch Ness. I'm trying to promote more rational thought, and I'll try to answer any question you've got. But how can I ever see the changes I seek when I can only set up shop 1 hour a week? This Week in Science is coming your way. You better just listen to what we say, and if you've learned anything from the words that we've said, then please just remember it's all in your head. 'Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in Science. This Week in Science. 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 This Week in 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 Science.